Ken, it's great. I think we've got this ready to go. So,
Sounds great.
Brian, thanks for joining us today. This is going to be a fun conversation around water, drinking water, potable water, and getting it from in a very different than anything that we're used to with piping a city to your house, into the house, etc. So, real pleasure to have you on today. Why don't you introduce us to yourself and to the company, and let's get started right there.
Sounds great, Bob. Thanks for having me. I'm super excited to dig in today and talk about different ways that we make water, but then also in the context of potential collaborations with ZenniHome. So really excited to be here. Well, quick introduction on the company and myself. I'm Brian Sheng. I'm CEO and founder of Aquaria. And at Aquaria, we're focused on addressing clean access to water by creating water from the air around us. And actually, so I'll demonstrate later when appropriate, but actually you see one of our machines right behind us. I'm sitting in my house today, and this is how I drink water. And so, happy to, I'm really excited to share more about Aquaria today.
Great. The technology of Aquaria's atmospheric water harvesting device is fascinating. We've seen a few things out there for a couple of years. Could you provide an overview of how these devices work and the key principles behind their clean and sustainable potable water from the atmosphere?
Yeah, absolutely. I think, Bob, you touched upon a really interesting point, which is how we get water today, and historically, ever has always been from the ground or below, whether that's a river, aquifer, reservoir, whatever it might be. But instead, where we're looking as the new frontier is we're looking to the sky for a new source of water. I think many people don't know how much water we have in the air, but at any given time, we have about 38 million billion gallons of water. And put that to context, even if everybody on Earth used 100 gallons of water a day, that's only 0.025% of the water available. The point is, there's a lot of water here. So the question is then, using our technology, how do we get water from the air into liquid form as effectively as possible? So actually, the principles behind it, I think a lot of us understand. On a hot summer day, we go into the fridge, we take out a cold drink, a cold beer. There's water droplets that form. So that's really the simplistic version of it is you have a cold source, you meet hot air, and then liquid condensation forms. But for us, using Aquaria's patented technology, what we're doing is we are using heat exchange materials, and then we're recycling the hot air, a source of hot and cold, bringing them together, and then that condensates liquid water in an energy efficient way. The secret here, or really the key point here, is making water from the air both high quality and as energy efficient as possible, because what that translates to is the cost of that water. And only by focusing on the R&D around this technology can we make clean water affordably.
Wow. There's all kinds of applications here we're going to talk about here in just a minute, but as ZenniHome focuses on providing sustainable and efficient housing solutions, how do you see the integration of Aquaria's atmospheric water harvesting devices complementing our vision for off-grid and environmentally friendly housing developments?
Yeah, absolutely. And actually, Bob, this, after I give my answer, I kind of want to ask you also about the ways that, how ZenniHome views sustainability, because that's really what attracted me to ZenniHome. About the company is about scalability, sustainability, and it's a modular way of building homes. Because if you replace those words for us, that's the same thing we look for. We're looking for a sustainable way to make a scalable but also modular way of creating clean water. So if we look at water today, and this is directly, I think, relevant to building homes as well, there's large construction process and there's a lot of time, permitting involved. Same thing with water. When you build a water facility, whether it's a treatment plant or a desalination plant, a lot of time, a lot of cost, a lot of people involved. But obviously for our living needs and our water needs, we need to be more flexible. So what was really interesting is, when I looked at the ability for ZenniHomes to be put in different locations and be able to build quickly, and then also using sustainable materials and incorporating different energy sources. That really resonated with me because when we think about water, we also have to think about the setting for where you use that water. And pretty much it's always, well, for maybe you can consider different, settings, but it's around a building, whether you're at your house or you're in your office or you're on vacation, wherever it might be, you get your water next to some type of property. And so being that, ZenniHome is able to be, you can construct ZenniHomes anywhere. And so thinking about how do you provide water for that, well, I think that's where some of the really interesting opportunities come. We can deploy water from the air, and that can be in various sizes, for something as small as this, all the way to 40 feet containers. But even 40 feet container is really small compared to the size of a big water facility. So I think it's like Lego blocks, and how to make them come together to provide a holistic solution for the users. I think that's where it's really exciting.
Well, one of the great opportunities we're thinking about, you take a state like Arizona, and we just had this massive controversy. The Washington Post just certified that groundwater, California's been using too much groundwater, and there may not be 100-year certified water supplies issued for bought land to build homes and cannot get the 100-year certified water supply. And so what we would like to do is offer what we call a planet-wise ZenniHome. The water that's off-grid, internet that's off-grid, and electricity that's off-grid. We already do the power with PV, inverters, batteries, off-grid. That's pretty straightforward now. We know that Ukraine and all of us, a broadband connection off-grid, and you can work from anywhere with the Starlink system. So now you're linked up for a telephone, and you have internet band in the world. Then you look at new sewer options, which we can talk about in a minute. But your solution gives us an opportunity to get water anywhere without all that infrastructure. Water treatment facilities, taking river water, canal water, lake water, and then trying to process it, clean it to potable standards, and then somehow pipe it to your house. It's a huge expense. So if we could build all of that in the factory using something we can buy, it just seems like you've just taken three of the four issues and put it completely to bed. We just need to work on sewer, which we can talk about in just a minute. So tell me how to scale this so that we could like build a whole subdivision in Arizona or California, providing potable your solution.
Absolutely. And Bob, I think this is a follow-up question for me is actually this directly relates to the sustainability part, because from our end it's actually fairly simple. We evaluate, well, it's always customer centric. So in this case, we collaborated and we asked, well, we're an expert in water production. I would love to understand, from ZenniHome's perspective, how you guys think about, let's say, water today. Like, how are you getting water today for the homes that you're building? And then also how you're thinking about like sustainability, because water and the use of that water is related to sustainability. And then, but on top of that also is that we need energy to produce water. Water and energy are always linked. And I also saw that there are a lot of energy options for ZenniHome. So I'd love to learn a little bit more about ZenniHome and how you're thinking about sustainability in that way for the product.
Okay, so let's just talk about each of these individually.
Okay.
First of all, the water that gets used in a home, the most ridiculous thing we do today is we take all this treated water that's been very expensively treated and then very expensively brought to a home, and we water our grass, we water our plants with potable water, and we run potable water into our washer dryer, our washing machine process, our showers, etc. And so we believe that what we've already done, and I don't think there's any other home builder doing this today, is that we take all the plumbing and we've created two different systems. So there's a system and there's a black water system. And so instead of having all water, it's just like water coming from the tap comes from one place, all potable, we're trying to be more sophisticated and divide it into two. Or if you're in a sink, if you're taking water from the washer dryer process in your home, it's going into a gray water system in our home. And it goes out to the edge of the house where you would attach sewer, and it's there waiting for you to be smart with that gray water, i.e. $400 on Amazon buys you a charcoal filter. That water can be used on plants, grass, whatever on the outside. So we're not wasting that water. Second of all, if it's a toilet or the garbage disposal, goes to black water. That black water today goes to your septic, sewer, or some kind of other. We are working with another company, Brian, like yours, called Busa out of Germany. For 20 years, they've taken that water and they've created almost drinking, and it's now approved in Arizona, Utah, and various states. And so we're looking at maybe a $10,000 unit that would attach to the black water, where we would actually capture 98% of the water that came in the home and turned it back into near drinkability to be reused. Now, if we could top up the unit, the Aquaria system, potable water that you would typically drink and maybe cook with, I think we have, without plumbing, we could actually keep a virtual supply from the street without any connection to street, sewer, water. We could keep a virtuous supply of water almost indefinitely without hauling water to the home with your system. What do you think of that idea?
I think it's really great to hear that there's a separation going on here, because I think that's one of the biggest strategies is to use potable clean water to waste it. There's so many communities today across the U.S. that don't have access to clean drinking water, and distribution of water and the recycling on a house-to-house basis. And also for commercial properties as well. That's a huge area of opportunity to create more sustainability around water use. So that to hear that there's this smart sewer process that can separate gray water, black water, and then the potential to stack Aquaria systems on top of that, I think that is a very efficient use of the property itself, and then the kind of the segmentation of water as well. Like just hearing about it, I can imagine. Because we mentioned about like scalability and larger properties, we can, for example, for tap systems, only the tap system, we can create clean water for cooking, for drinking, and that can be dispersed around the entire commercial property, no matter how big. And then because if we look at the average amount of water use per day, you obviously want to drink about 3 liters or like at most a gallon of water a day per person. And if you account cooking water and life water, where you need potable water quality there, then you're talking about, let's say, maybe 30 gallons a day, 20 to 30 gallons. That's really already a lot. And so, one of our machines that produce 250 gallons can easily serve 10 families or 10 units, up to 50 people. You can put that on the roof, you can put that on the side of the building, and then the configuration could be well, really whatever is needed. Because for us, we can produce units like this that are just, it just sits on your countertop, and the experience is not very different from even having a water cooler. The only difference is there's no water source except the air. And then you can have larger units that can connect to a tank or connect to your plumbing, or just be a dispensing machine by itself. So I think all of those are great possibilities depending on where the ZenniHome is deployed and what the needs might be.
And Brian, how much water will the unit on the counter behind you, how much water can that make a day? in your home?
So this unit behind me, which the camera might be a little bit skewing, but it's basically the size of my head and my shoulder. So it's kind of like a microwave size unit. This unit can produce up to about 3 gallons a day of water. Now, if you're in a drier area, it might produce 1.5 gallons. Really dry area might be around a gallon or so. But that's really the range. This small unit produces enough water for the family to drink, up to 3 gallons a day.
No need to have that outside. It just sits on your counter and uses the.
Correct. Yes. So this unit, because the capacity is only 3 gallons, you can put it really anywhere. And then for our larger units, because we're creating large volumes of water, we have to put them outside so they can consistently draw in more air and create lots of more water. And plus, you probably don't want a 20 feet container in your home anyways if you are getting to that large scale of water production. Put it in your backyard, put it in a shed, in a shed. As long as there's open airflow for the larger ones, that's no problem.
And Brian, I know you're starting and you're raising money on WeFunder like we are. Can you give us just a real sense for where the retail price to be for these units? The one leading up to the one that you talked about that could do 250 gallons outside.
Sure, absolutely. So our units, so actually let's start with the units right behind me. This unit will retail for just $1,000. This is our most affordable unit, and we want to make it as affordable as possible. So this can be bought by anybody and just straight through e-commerce and then use this unit. And then our units, let's say the 250-gallon unit, that's a slightly large unit. It's about the size of a dining table. And that unit retails for $30,000. And then we have larger units that goes up to the container size, which are 6 figures and more commercial in nature. But because of our WeFunder campaign, our goal right now is really to spread the message and let people know that Aquaria as a technology today exists. It is a form of technology that's not in the movies. It's here today. If you wanted to drink water, this is how I drink water. So if you go on WeFunder campaign today, we're offering discounts on all of our models to make sure we get our early customers who are our supporters and that they can be supported equally on the pricing.
Excellent. Okay. So you 1,000, the unit you talked about that might be able to handle 10 families would be in the neighborhood of 30,000. Is that accurate?
Correct.
Great, Brian.
Yes, correct.
Thank you. Thank you so much for that. I'm sure everybody's asking of us right now. So we're partnering with the Navajo Nation to address the housing crisis on the nation. And over half the people that live on the Navajo Nation do not have running water. And they actually will haul totes in the back of their pickups with 250 to 350 out to their home. They call them scattered home sites on the nation. It's the largest nation in the country, the largest Native American nation, and it's the largest as well as population. And we want to help them. It's 20, 30, $40,000 to, even if there's a water line nearby, to get that water to their house. So they keep one of these totes in the back of their pickups and fill it up in town and bring 300 gallons out to the home on a consistent basis, maybe several times a week. Have potable water at the home. So we would love to consider your expertise in this area. And could you envision a potential ZenniHome and Aquaria and the Navajo Nation to collaboratively address both housing and water challenges, working together to create a more sustainable and impact on the community, the Navajo Nation?
I think this is a very much a value alignment for us to be able to collaborate in that way. Aquaria is not just a water technology company. We're formed as a public benefit corporation, and our mission is to unlock access to clean water. And while we're a for-profit company, our mission is very important to us as well. In fact, right now I'm based in Los Angeles. We're working directly with the city of Los Angeles and the sustainability office to figure out how we can bring our solutions to underserved and frontline communities that have clean water access challenges. So when I was talking to David the other day about the possibility of deploying to Navajo Nation, that was super exciting to me because on Navajo Nation, I've done my research, and infrastructure is a huge issue. And so having the ability to, well, it's having the ability to bring our product to those most in need. I think that's a super exciting opportunity. And it's also really big props to your company, Bob, to be able to work with Navajo Nation as well. I know that's not an easy partnership to achieve.
No, there's been, as you can imagine, the First Nations in Canada and the Native American people in America. I mean, they were here first, and we kind of came second, and have relegated them to reservations, lands by the federal government for them to occupy. And it's all the way around has been a bad situation for them. And so to be able to come back, and they have 52% unemployment, over don't have water or even a bathroom. They're going outside to a john to go to the bathroom. They don't have sewer systems, no bathrooms. 90% of the homes on the Navajo Nation are considered unlivable. They bought something very, and have lived in it longer than its life expectancy. So there's 40,000 homes, of which 90% have to be replaced. There's only 6,500 homes on the entire Navajo Nation, livable, safe homes to live in. Fix that, but we need to solve the water. The culture prefers living in a Mother Earth, Father Sky, long ways away from each other, with sheep and other animals that have helped them survive over the years. They don't like to live in clustered communities. So it's very difficult to get scale for power, for water, for sewer out to these scattered home sites. So this is a perfect solution where we could bring them homes from the factory that come equipped with all of the things that they need to live a modern lifestyle, and still live remotely in their scattered home site. It looks like it could be really ideal to work together on this. Can you tell me how is going to work, and how many units you'll think you'll be able to build? And I'd also like you to address the taste of the water. I know in your water, it's missing some minerals that we typically taste in water, kind of mineral additive that happens so that it tastes like drinking water out of a water bottle, for example, you might buy.
Yeah, absolutely. So the water we create does have trace amounts of minerals, and the taste, we've done a lot of work around our purification and filtration technology to make sure the taste is top quality. And we also have the option, and this is actually a request we get from different customers, commercial customers that are looking into drinking waters specifically. For example, we have a customer right now who is looking at a 100,000 gallon water facility to do bottled water, packaged atmospheric mineral water. So their request would be, we want XYZ alkalinity or minerals, and then we do a custom order for them to be able to create a profile of pH or profile of minerals on top of that. So that's simply a custom filtration addition. So basically, once the clean filtered water passes through, then we run that through an additional set of mineral filters, so we can remineralize the water for the needs of the customer. And this we found out that even tastes sort of vary in between different countries. Not everyone likes the same type of tasting water, and have different preferences there. But yeah, so that's more customized to the need of the customer when we're talking about larger scale deployments of units. Um, we currently have the ability, like I mentioned before, to produce units like this size, all the way up to 40 feet containers. And we're not at that scale yet, but our production facility is capable of producing up to 10,000 units of this. This is called the hydro station. Um, we can produce up to 10,000 units of this per year at the moment. And then that's actually why also we are raising capital right now, so we can increase our awareness in the market for our product. Right now, we have the capability to support of our own demand right now, and then for our larger units. They are more on a ad hoc basis, but we can also produce about 1,000 of the large units per year now, right, as well.
Do you have any idea how long this might last, the unit behind you, without a lot of service, and how much power it might consume?
Yeah, sure. So the power rating on the machine, so the machine is rated to last for 5 years, and the large outdoor machines are industrial commercial grade, so they're rated for 10 years, and actually. I have to mention that this machine should not be placed outdoors. Actually, this is supposed to be an indoor household appliance versus the outdoor units are supposed to be outdoor, so they are made to be to withstand Mother Nature. This type of unit looks, quite sleek. It's more supposed to be like an Apple-like product for your home. Should not be standing in the rain outside. Anyways, yeah. So this unit by itself, the maintenance you need to do on the machine is really just changing the filters once in a while. When I say a while, because it is related to the quality of the air around you. If you are in a place with fairly good air quality, then the frequency of change of the filters is fairly low, maybe once every 6 to 8 months. If you're in a place, uh, I won't say exactly where, but we've also deployed our units to cities that have very, very high pollution. And in those cases, we've had to change filters as frequently as once a month, because the air pollution was just way too high. And so it would clog up the filters. But then you just have to, that's just because the source is the air. We have to make sure the water quality is high, but we have to make sure the purification and filtration is done properly. So really ranges, but I would say that for most places in the United States, I think we're looking at once every 4 to 6 months should be enough to change the filters.
And then the power rating, how much power does it take to run the unit?
Yeah. So our units, we produce water for roughly around 250 watt hours per liter. So this is a 300-watt unit. And so this, again, this is a household unit. And then our large machines, the Hydro Pack, the 250-gallon unit, that's rated at 11 kilowatts, because that's producing up to 250 gallons a day. And so roughly the numbers are all around 250 to 300 watt hours per liter of water, so that you can multiply that by whatever the production amount, and you'll understand how much electricity it consumes. But basically, the math we do is it takes about 1 kilowatt of energy produces about 3 liters to or let's just say 3 liters of water. So then the cost to produce that water, but depending on your electricity cost, is a couple of pennies.
Yes. So if I'm in Phoenix, Arizona, I'm paying 12 cents for 3 liters. I might be paying 4 cents for a liter of water.
I would Well, actually, Bob, I would have to say that in Phoenix, Arizona, where the humidity is perhaps
Oh,
sometimes is very, very low, then I would say that calculation would be a little bit more, because just like
mhm.
solar, if there's cloud cover, then not as much sun, it wouldn't produce as much electricity. It's the same for us. So there is a band for production. But even if you said 1 kilowatt made 1 liter, then that would be around, well, that would be 12 cents. Um,
Right.
so it depends on the humidity level to really, but that's the maximum it would take.
And that's 12 cents for a liter of bottled water. That's a bargain. Okay. So that sounds wonderful. So any other questions we want to ask you before we turn it over to the audience? We've talked about power. We've talked
Actually,
about
I would
this.
love to know a little bit more about Power Bob for the ZenniHomes. I know that it comes with a solar option and maybe even batteries. I would love to, ask you about how that's placed on the ZenniHomes.
Well, we got our first power bill last month for Mesa, where we have our unit in a what we call a grid tied. We've been operating for 4 months any power from the city, and we
Mm.
did a net metering deal with the city. And my first power bill was $10. So most of the power needed for ZenniHome was coming from the solar and the battery, and just tapping into a little bit of power from. If you think about it, during the middle of the day, you're probably making more power than you're using with solar. We have 10 kW on top of our citizen unit, 10 kW. And so you're
Mm.
probably sending a few electrons, dribbling a few electrons to the city. And then during the night, maybe early in the morning when the battery's depleted, you'll be using a little bit as you get up in the morning from the city. So we're guessing that we'll see how many over the course of the month we're able to not use from the city and have a net balance. We're hoping to eventually get obviously to a net zero electricity use, but that'll take more years to get more efficient on everything that we use. But this is great that there's 12-cent bottled water possible with your product in our homes. We use a little bit more electricity, but you're not out buying bottled water with the Aquaria unit in the home. And it's not that expensive, I think, as an option. It would be wise for every single person that's buying a unit that they would get this standard with their purchase of our homes. And I'm really excited about not having to see the Navajo families haul water from Page, Arizona for an hour out to Kaibito chapter employees live.
Mm.
It'd be lovely.
Especially if you mentioned like community living, and so
Yes.
small communities, you can have a Aquaria water station, hydropack, let's say even in to serve multiple families it doesn't even have to be piped or into a tank. It can simply just be a standalone station, and people can just fill up their water using the communal station that stands there without having to pipe it through. I mean, obviously piping it to the home could be an option, but then also you could not pipe it and just have it there. And then we have even for our larger machines, we have the free dispense option, just like this machine. So you can just press a button and use, we have 4 dispensing hoses, and so you can use it as a standalone water station as well.
Great. Great. Let's see. I'm gonna you ask me a few questions, and then I'm gonna pop up my Slack screen here and make sure that we're getting all the questions from the audience here. So go
Yeah. Okay.
ahead. Do you have any questions for me, Brian?
Yeah, absolutely. So we talked about Navajo Nation, and then also Bobby mentioned the Mesa in Arizona property. So where are the locations you see ZenniHome focusing on deployment? Is it more focused on off-grid and remote opportunities, or is it or is it it's just or everyone, anyone, everyone? Who are other customers that are using ZenniHomes?
People, you talk about the prepper industry that wants to be off grid and completely not dependent. So there's some areas where we're close in Arizona where people that are trying to get completely off grid, they're hot real estate markets for that. And Snowflake, Taylor, Show Low area of Arizona, Stafford, Arizona. There's a lot of people moving there that want to be completely off grid, and there's going to be definitely a market segment for that. I'm going to guess half of the homes that we supply for the off grid because they just don't have the utilities to their land. So that's going to be a big part of that. Today, probably half of our units are leaving the factory with solar, as an option on the homes. So maybe half the units that will want to have a completely self-contained solution. And you've just made
Mm.
it easy for us to make water check the box that here's water for that. You can get the water you need for a lighter use, one or two people kind of opportunity. Somebody's asking us here, are regulated by any government agency? Is there any kind of regulation approval or something that's needed?
Yeah, so for atmospheric water generation as an industry, it's very new, and organization like ANSI are just starting to come out with some initial. I wouldn't even really call it regulation, but at least some frameworks around this technology. The short answer is atmospheric water generation products are not regulated. However, since our product is potable water, we do extensive testing in locations that we operate in. So water quality reports that are achieving either EPA standards or WHO drinking water standards. And we do that test in many different locations. Like we have reports from LA, Dubai, Singapore, South Africa, different places, Bangkok. We do testing all different sorts of locations to understand variances in water and how that relates to variances in air quality, for example. And so that's why we do testing in a lot of different locations. So I would say that if there was a regulatory body that's relevant to us, it's really EPA or WHO drinking water standards and making sure that the water we produce is according to that. Otherwise, we've even tried to go for, let's say, Energy Star ratings. We don't fall under a category. There's no category for Energy Star for atmospheric water generation and other bodies. It doesn't currently exist, but we're trying to push the boundaries and try to get as much as relevant or proxy like water quality that's important to us results.
Great. There's a couple other really good questions. Is it a 110 volt for the unit behind you, or is that a 220, 240 volt? What
This
kind
is a
of,
this is a 110-volt unit.
great, super. So it plugs in like any or anything else in your kitchen.
Yes, correct.
Excellent. Another question that I've seen here is one gentleman, John, said this seems to be one of the most revolutionary developments in human history. How will this improve over time, Brian?
Absolutely. So I think I can draw a parallel to solar technology here. Solar has been well researched over the past 30 years, I think, since Bell Labs. And only recently, over the past couple of years, has it become more affordable to open up a new solar production, energy production plant versus even burning coal or opening up a new coal plant. So there has been a tipping point where it's actually more economically affordable to be sustainable and green than it is to use the alternative. Of course, there are still other challenges with solar, but that's a crucial tipping point where it's more affordable to be green and sustainable than it is to use some other more carbon intensive option. So while we have done a critical step in doing the R&D and creating Aquaria's current technology, our holy grail as an atmospheric water technology is when we can create water cheaper than tap water, where we can create water from the air cheaper than it is to get water from the ground. Or even if we're close, even if we're, let's say, within, so right now we're still probably, I would say maybe, depending on where you are, maybe 5 to 7, 8 times more expensive than getting water from your tap. So if you had tap water and that was high quality, this is more like a Apple product to you, but really we're serving the needs of people that have water access issues today, which is already lots and lots of people, and that's why we're here talking about it today. But in the future, and actually not even in the future, today, some of the technology, some of the R&D that we're doing at Aquaria, for example, is looking at, for example, integration with hydrogen technology, being able to produce water from the air using hydrogen, and then also in downtimes be able to create more hydrogen to power ourselves through electrolysis to become more energy self-sufficient, so that we're using our own energy to produce more water. Again, the different methods all come down to one thing: how can we produce more clean water more affordably? And that's really the future for this whole technology category.
Great, very visionary. Thank you. So let's just think big picture. I know when wind turbines came along, people, here's this resource that's kind of flying through the air, literally wind, and we're going to harvest that and turn it into electricity to power our homes. And then people start looking at bird kill. Oh my gosh, the turbines make a little bit of a swoosh noise. Is there something bad? Some questions I've heard about atmospheric water harvesting is, if we remove all this humidity from the air, what's the negative on that? Does the
Mhm.
house, does your home feel a little bit more, because air conditioning already been doing this to some extent, versus swamp cooling of your home? What are some of the negatives that we have to be just on the lookout for as we remove humidity from air?
Sure. So because water from air is water from the air, so we do definitely you if you're in an enclosed space, a very small enclosed space, then you would have the humidity decrease in that area. So um, when you use our machines, this is part of using the machine, is that you should have airflow in the area. So for example, you shouldn't put the machine, let's say, in your bathroom where there's maybe 10 square feet, 30 square feet, whatever of space, and that's the only place air might be in, versus being in your living room where there's more open space. You should put it in your living room where there's more open space, because you need more airflow for the product in order to create that water. And if you put it in too tight of a space, it's very noticeable that you have a decrease in the humidity of the air. And that for some people could become a little bit uncomfortable. That definitely is something to notice. I mean, I live in LA. This is my living room. It's creating water, so I want to mention that, but it's not super exaggerated, since LA is not exactly the most humid place either. It's still quite dry in LA, so I feel no problem. Actually, I have two of these in my living room. I don't have one, I have two, because I have my family lives here, so we need a couple of us, so we need more than one machine here. But that's definitely something to be mindful of, is to understand that where you place the machine can have an effect on the comfort based on humidity of the location.
And Brian, would you say that you don't notice it? They're there, but you don't notice any difference in terms of living condition. Your skin's
Uh,
not more dry. Go ahead.
so yes and no. I have to be honest. I've put this in my room before, and in my room is not that large of a space in LA. I don't notice this at all when I'm in Texas or in
Hmm.
Florida, for example. But since
Hmm.
LA is already quite dry to begin with, there are times that I do notice it when I'm um, in my room, and I'm putting in my room. This is why I mentioned the living room, because in the living room there's more open space, and that's not really as much of an issue. I definitely do not recommend putting the machine like right next to your bed, for example, in a very enclosed space when it's very dry. This is all related to the humidity. While it's we think it's super revolutionary, there are definitely some things that's related to the fact that we're pulling moisture from the air. So that's it really isn't noticeable for me in the living room. It is in a dry place in my room. So that's something that I shy away from.
And I'm just thinking, I think there's just, to your point, when we first started, there's so much air, so much moisture in the air that we're not going to suck too much moisture out of the air. How many times more than what we need, did you say was in the, it's a map there that was pretty fancy.
So that is a very common question, Bob, I get, is if we deploy so many atmospheric water generators, can we suck the air dry? Um, so the calculation I did before was that if everybody on Earth used as much water as Americans did, a lot of other countries definitely don't have water as much as we do, but if everybody on Earth, 8 billion people did, we would only be using 0.025% of the available water. And I'm happy for anyone who's watching the audience to fact check me on this. But this is really the math behind it. Obviously, humidity varies based on climate patterns. Your humidity in Florida is not the same as your humidity in Phoenix or in LA. But generally speaking, even if you use all of that, it would only be 0.025% of the available water in the air, just in the air. And if we remember back to Earth science, the Earth's natural hydrologic cycle, about every week or so, 7 to 9 days, all of the water on Earth gets replenished through just rain, evaporation, and in the process of the Earth's natural cycle. So that 0.025 number is not like we're using it and then we're depleting it. It's just using it at that particular point in time. If all 8 billion people drew 100 gallons a day, but that's getting replenished every second through the cycle. So that is not an issue.
Brian, I love that you've done your math on this, because you can see some crazy people saying, oh, you're going to change the climate. So you have Earth doing this every week or so, all the moisture is replaced in the air, and we're taking out a tiny, tiny 0.025% of the water. If everyone on Earth was using 100 gallons per day of water from the atmosphere. So what it comes down to, in my opinion, is humanity has always settled on a lake or on a river, before we could really drill deeply in the ground and get groundwater, fossil water out of the ground. That's the travesty. Example, our groundwater, it took thousands of years to store in fossil deposits of fresh water. And we're taking it out in a decade or two. So you just think about it from an Earth perspective, we are depleting these stores of water in the ground, where if we took your approach, every 7 days, Earth is replenishing the air with, and if we took the humidity from the air to live with, in complete harmony with Mother Earth. I'm a big fan here today to say, Arizona, start harvesting. California, Southern California especially, it is dry. Start taking more of the water from the air that the ocean's kind of helping us put back into the air, and let's stop taking water out of the ground, which took thousands and thousands of years to put there at the levels that we have been using at that could literally in just a few years. There's another couple questions with that. So we talked cost. You had a customer that said that your unit works great. You said you were very helpful in getting your system delivered, and so there's a happy customer that's commented here.
Oh, great. Thank you very much.
And then what happens when your unit's running when you're not home? Do you have how much water can you store in the unit? And what happens if it's generating water while you're away from home for a while?
Sure.
How does that?
So this unit behind me right now, it's full. I haven't drank water today. Actually, a little thirsty, but right now, if you see, I can actually turn this machine a little bit around. But on the side of it, this is the water tank, and so we store 6 liters of water in the water tank. And right now, the machine is actually just off because it doesn't need to produce any more water because it's completely full. It would start making water again once I, well, get a whole glass of water here. But essentially, it controls itself. Once it's full, it stops producing water. And then once it gets to a certain level in the water tank, then it would start producing water again. And then it would stop again when you're not using it. Sorry, when it gets full again. However, I do have to mention that because the water is constantly filtered, again, remember we have to make sure the water is high quality. So the water is consistently being disinfected through UVC and filtered through the machine to make sure that it's high quality. When you have water just sitting dead in a tank and not moving, that's when bacteria and other types of contamination occur. So when you're away from home, you still leave it plugged in. It just cycles itself. It won't be making water because it will be full, but you leave it plugged in and it will cycle itself every 3 to 4 hours. And so that you don't have to worry about it. The only thing you shouldn't do is turn the water off.
Okay, so when you say recycle every 3 or 4 hours, what's it doing? What's the mechanically is that tank of 6 liters of water doing during that that recycling process?
Sure. So the UVC light will turn on in the tank, and UVC is for disinfection. And then
Mhm.
apart from that, the water actually runs again, circulates through the treatment system again to make sure that it's flowing and then maintaining that quality. So that's what I mean by dead water versus moving around, circulating. Is that it's obviously most of the energy is consumed in actually producing the water, so not a lot of electricity is consumed. It just runs itself through once every couple of hours.
Great. So I have Tim asking us what our industry competitors are, and I think I mentioned before worked with and talked to Zero Mass Source out of it's an ASU spin out.
Mhm.
So Brian, tell us what the industry is doing.
The industry is very nascent. I would say that there's maybe half a dozen companies that are tackling this challenge of water access through the air globally. Maybe now we have maybe a dozen companies or more. So it's definitely of quite a nascent industry. I would say some of the more prominent companies. One would be Source and Zero Mass Water in the U.S. One might be a company called Watergen out of Israel. But there's very few companies that are working on atmospheric water. And to be honest, I think that's a
Yes.
problem.
Uh-huh. Uh-huh.
That's a huge problem.
We need
I
more
wish there were
company.
way more companies. I think there's like 5,700 solar companies in California alone.
Uh-huh.
Um,
Uh-huh. Wow.
so yeah, so it's kind of crazy. But those would be some of the other competitors that are I would say competitors in the sense that they also are in the business of making water from the air. But I don't
Hmm.
think they're competitors because in this industry we need way more companies addressing water, and two, we're also creating water in different ways. So um, you know for example, we make water. How we make water and what we focus on is very different from how Source and Zero Mass create water.
What would be the difference, Brian? How they do it and how you do it?
Sure. So Source Water, for example, focuses on energy and water in one product. Their hydro panel is at once both a atmospheric water generator and also a solar panel. So they are a self-contained unit um, that, well, it powers itself. The great part about that is obviously it powers itself and it's a self-contained unit. And so once you've deployed it, it's supposed to run, well, by itself. For us, we chose a different approach where we said we are agnostic to the energy source. We can plug it to the grid. We can plug it to solar. We're not the solar experts. We're not the battery experts. And we're also looking into hydrogen production, although that we're actually looking into developing our own technology around it. But our expertise is we want to focus on large volume and low cost water production, regardless of how the energy comes to us. And so if you look at a source unit, we need the energy versus source does not need the energy, but for a unit of the same size, given that energy is provided, we can probably produce 50 to 100 times more water given that space constraint. But we still need energy versus sources product does not need energy. As long as the sun is shining, their product will produce water. So that's what I mean. There's a lot more R&D needed in the industry because just like wind turbines, and other technology, there are certain places one product works better than the others. And for us, we chose to be agnostic of an energy source, but to focus on high volume production and low cost production.
Great. There's two other quick questions before our time is up, Brian.
Okay.
Someone asked me, our battery storage units, we have a 10 kW system panels on the roof, an inverter, but if you add the battery's about $5,000 or $6,000 for 10 kilowatt hours of lithium ion battery storage. There's another question for you that people are asking: how does Aquaria address air? So interesting question.
Yeah. So our machine doesn't just have water purification, it also has air purification. So we have HEPA air filters on the back of the machine. So actually the first thing that our machine does when it draws the air in is to first clean the air. So the first thing we do is make sure that VOCs, particulate matters, pollen, any of the things, we have to make sure the air is clean first. And so actually, let me see if we can view it. I'll turn the machine around a little bit so people can see it. But on the back of the Aquaria machine, this is the first pass. You have to go, the air gets drawn in, and the air itself is actually purified first before then it goes into the inside of the machine and the water gets purified. So it's a multi-step process to make sure that the source gets cleaned before it's made into water. Now, goes back to my answer before. This is where the air quality matters. And we've taken off some air filters where it's in bad shape because of the quality of the air that the machine is working in, because our customer asked, we got the machine for like 3 weeks and it stopped working. Why? And we're like, well, that shouldn't happen. And then we said, well, why don't you take out the air filter and see how it looks? And it was quite in bad shape. It was completely clogged and no air was even getting through anymore because it was just so clogged. And so that's what happens with the air filtration.
That's great. We could get into COVID and taking all of the things out of the right now. That's a good a secondary benefit of what you're doing, cleaning up the air in your home. Great. Do you, Brian? It looks like we're right at our time to end.
Well, I guess my final comment is I'm super excited to explore. Really, I really explore how to partner with ZenniHomes to put our water unit and become a water source, whether standalone or actually become an SDK in the ZenniHome factory to provide water for your customers. And then really also want to dig into some of the really interesting opportunities on Navajo Nation. I think that's two birds with one stone, providing a great technology product, but also solving a huge problem for the community there. So super excited to see if we can collaborate and really, bring the whole solution to the people.
Thank you. A pleasure. And it's given a whole new opportunity to us looking at this planet wise, how we can provide in a remote location, don't have water, don't have internet, do not have sewer facilities, and do not have electricity. And we would love to be able to have all of that wrapped up together in a package in the factory. So when it comes to your site, you can live a normal modern lifestyle with all of the conveniences of being in the middle of a city, with all of the utilities being brought. So thank you, Brian. Very interesting. And I'm really glad that during COVID you got after this. I understand you said this was a theme. When you were going to college, you were working on this idea. Let's just let you wrap up on how did you come up with the idea to start this company?
Yeah, so prior to founding Aquaria, I was actually a frontier tech venture capital investor for about a decade. But when I was thinking about my next career move and more newest innovation I wanted to work on during COVID, I went back to something I did in my past life. My senior thesis research at Princeton was on atmospheric water generation and its potential to address the water crisis. Thesis research angle into Aquaria. So put my head down for 2 years, and now we're coming to market and hoping to democratize access to clean water.
Brian, I want a copy of your thesis. If you want to send it over, I would love to read it. And we'll start thinking big picture how we're going to solve this world's problem. Thank you very much for joining us today, and looking forward to it, and hope everyone enjoyed this informative webinar today.
Thank you
so
Bob,
much. Really quick, we just dropped links in the chat for anybody interested in learning more about ZenniHome or Aquaria, or investing in either company. We are both fundraising right now and are on WeFunder. So please do go check out the chat, and you can find all the links that you would need there.
Yep, it takes a nice shareholder group to thrive, and appreciate those who want to become part of our community or part of Brian's, or both. Why not invest a little bit on WeFunder to solve housing and getting potable, clean water for every single person on the planet. Thank you so much. See you soon.